Welcome to HoloBio, the open source interface for digital holographic microscopy. On the main menu, we have two main panels, one for real-time acquisition and the other for post-processing. Both panels include options for DHM and DLHM. In this video, we are going to select real-time for live DHM acquisition. This is the DHM real-time package for real-time processing. On the main screen, you will see two areas. On the right, the visualization windows, and on the left, the parameters controls. At the bottom, you can also monitor performance. Here you can see the FPS at which the camera is at current frames. And here you can see the reconstruction display FPS, which reflects the processing speed. Before starting, make sure your DHM setup is properly connected and the camera drivers are correctly installed. From the toolbar, click Load. You can either load a video or connect directly to the camera. For this part of the tutorial, we will connect to the camera and we are using a Mac sender setup in an off-axis configuration. Now let's set the system parameters. In this case, the wavelength is C33 nanometers and the pixel size is 3.75 micrometers. Next, in the filter transform mode, choose the filter geometry, circular or rectangular. With everything ready, click Compensate to start the reconstruction. Now, it's important to select the operation mode. There are three reconstruction modes able. Alignment mode that is continuously updates and refines the carrier frequency positions in every frame. This is mainly useful during system alignment or when the diffraction order is moving. Second, acquisition mode freezes the FX and FY position and makes from the previous frame. This is ideal when the system is stable and higher processing speed is required. And last, align once updates the FX and FY only in the next frame without continuous refining. This works as an intermediate option when a small adjustment is needed. Additional, you can choose between using vortex-only compensation or vortex legendre compensation, depending on the level of phase correction required. If you want to save a video, use the record option panel. You can choose to record the hologram phase or amplitude. Press start to begin recording and stop where you are done. Finally, you set the file name and pick the folder when you want to save. For the second part of this tutorial, we're going to explore how the particle tracking section of the interface works. First, we start to load a video. This will be the sample where we want to track the particles or the objects of interest. Next, we select the type of filter to apply. There are two options able, Gaussian filter and bilateral filter. The option depends on your sample. For example, if your sample has a lot of noise or texture, the bilateral filter may preserve it better. Then you can decide whether to use the color filter by acting or disactivating the corresponding button. If you enable it, you will need to set the blue color value to either 0 or 255. Use 0 when the background is bright. Use 255 when the background is dark. After that, specify the minimum and maximum area in pixels of the particles or the samples you want to track. This helps the algorithm ignore objects that are too small or too large to be relevant. Next, configure the P, Q, and R parameters of the Kalman filter. These parameters control how the algorithm predicts and corrects the position of the particle in each frame, improving the continuum of the trajectory. Finally, decide how you want the result to be displayed in pixels or in work coordinates, for example, micrometers. If you choose work coordinates, activate the corresponding button and enter the magnification value of your optical system. Once everything is configured, press the tracking button and the software will automatically detect and follow each particle across the video frames. Finally, when tracking ends, the graph of the object's trajectory appears where the dots indicate where the sample begins and the X indicate where it ends. In addition, we obtain a table with the X and Y position for each of the particles in each frame and the elapsed time.